Hi, this is a lecture on lines and angles. First, let's go over the basics. This is a line segment. A line segment is a portion of a line between 2 points. This is a ray. A ray is a portion of a line with an endpoint. And this is a line itself. Keep in mind that lines may be represented by two capital letters, which are points on the line itself, or by a single small letter, say L, M, N, etc. Now let's look at classification of points. If three or more points lie on a straight line, then they are called collinear points. If the set of three or more points do not lie on a straight line, they are called non-collinear points. Keep in mind that there is no point in discussion of a set of two lines because you can always find a straight line which passes through two distinct points. In fact, it's an axiom itself. Next, we'll look at classification of angles. An angle less than 90 degrees but greater than 0 degrees is called an acute angle. An angle equal to 90 degrees is called a right angle. An angle greater than 90 degrees but less than 180 degrees is called an obtuse angle. And an angle equal to 180 degrees is called a straight angle. While an angle greater than 180 degrees but less than 360 degrees is called a reflex angle. Next, we look at some other terminologies associated with angles. That is, if two angles share a common vertex and a common arm, and the non-common arms are on opposite sides of the common arm, then the two angles are called adjacent angles. In this case, angle ABC and angle CBD are adjacent angles. And if the non-common arms of two adjacent angles form a straight line, then they are called a linear pair of angles. So, angle ABC and angle CBD form a linear pair of angles. In this case, vertically opposite angles are defined as the ones which are obviously vertically opposite to each other. And so therefore, in this case, angle AOD and angle BOC are a set of vertically opposite angles, as well as angle AOB and angle COD. This is a set of vertically opposite angles, and this is a set of another vertically opposite angles. Now let's look at some axioms which are there in discussion of lines and angles. Axiom number 1: if a ray stands on a line, then the sum of two adjacent angles so formed is 180 degrees, which is pretty much evident from the picture itself. Obviously, there is no proof to this statement because this is an axiom. But you can look at this. Angle ABC is 1 and angle CBD together form two adjacent angles, and because they lie on a straight line, this angle as a whole should be 180 degrees, and this. So therefore, angle ABC plus angle CBD is equal to 180 degrees because AD is a straight line. Now, if the sum of two adjacent angles is 180 degrees, then the non-common arms of the angle form a line. Again, this is an axiom. There is no proofs, so to speak, attached to it, but you can see it in the image itself. Now, let's look at the first axiom of this lecture. If two lines intersect each other, then the vertically opposite angles are equal. You remember we discussed vertically opposite angles here, and how AOD and BOC are vertically opposite angles, and the other set is given here. So this is a theorem which states if two lines intersect each other, then the vertically opposite angles are equal. Let's try and prove this. So we have to prove angle BOC AOC is equal to angle AOD. Or we could have proved the other one, that is angle AOB is equal to angle DOC. I mean, both of them are vertically opposite angles, and if we prove this, we basically prove it holds for the other one also. So let's look at a way to do this. Now we can do this in many ways. The easiest way to do this would be like so. Consider the line AC and the ray OD. In this setup, angle AOD and angle COD are adjacent angles and also form a linear pair of angles, and so therefore angle AOD plus angle COD is equal to 180 degrees, because AC is a straight line. Also, look at how BOC and COD form a linear pair of angles, because BD is a straight line, and so therefore angle BOC plus angle COD is equal to 180 degrees. Let's call this statement number 1, and then let's call this statement number 2. Now if we subtract 1 from 2, we get angle AOD minus angle BOC is equal to 0. This implies angle AOD is equal to angle BOC, which is what we had started off to prove. Keep in mind that we can prove the equality of AOB and DOC in a similar fashion by considering AC and BD. Next, we will look at parallel lines and transversals. Keep in mind that transversals are transversal is a line which intersects two distinct lines at two distinct points. There is some terminologies associated with the angles that a transversal makes on intersecting parallel lines. Angle 1 and 5, 2 and 6, 4 and 8, and 3 and 7, that is 1 and 5, 2 and 6, 4 and 8, 3 and 7 form sets of complementary angles. Next, there is a set called alternate interior angles, which are 4 and 6 and 3 and 5. 4 and 6 and 3 and 5, opposite basically. And alternate exterior angles, which are 1 and 7, 1 and 7, and 2 and 8, 2 and 8. Interior angles on the same side of the transversal are 4 and 5 and 3 and 6, 3 and 6. Also, there is a broad category. We were talking about interior angles and exterior angles. They themselves are defined. So, interior angles in this case would be 4, 5, 3 and 6. Basically, these angles here, because they sort of lie in the interior of this geometry. Not very strictly, but they do. So angle 4, angle 3, angle 5, and angle 6. And exterior angles are angle 1, angle 2, angle 7, and angle 8. Basically the ones which seem to, so to speak, lie on the exterior. The reason that we're defining these classifications is because these sets seem to have very nice properties that we will look at now. Axiom number 3, if a transversal intersects two parallel lines, then each pair of corresponding angles is equal. That is to say, 1 is equal to 5, and sorry, angle 1 is equal to 5, angle 2 is equal to angle 6, angle 4 is equal to angle 8, and angle 3 is equal to angle 7. Next axiom is, if a transversal intersects two lines such that a pair of corresponding angles is equal, then the two lines are parallel to each other. Basically, axiom 4 is the converse of axiom 3. Now there's a lot more to follow on lines and angles. We will take that up in the next lecture. For now, this is all. Thank you.